Here we are. So we do have Luke Marsden with us, and he's going to be speaking to us on metadata and data logging system for facilitating fair data publishing. Thank you very much, Luke.
Thanks, Jonathan, and thanks everyone for having me. It's nice to be here. I'm Luke, and today I'm going to talk about some work that I've been leading alongside Olaf and Vitaly as part of the Nansen Legacy Project. Nansen Legacy Project, amongst other things, investigates the role that climate change has been having on the Northern Barents Sea. And at the centre of this project have been these research expeditions on board Norway's flagship icebreaker from Stockholm that you can see here. The project is drawing to a close at the end of this year. But for the past 3.5 years, it's been my job to firstly provide an overview of all the data that we're collecting, and secondly, to help all the researchers across the project publish their data in line with the FAIR principles, as is written in our data policy. It's a large project that involves 280 people from 10 of Norway's top research institutions. And it's multidisciplinary, which is great for science, but makes my job somewhat more difficult. And that's for two reasons. Firstly, we need to find a way of making the biologists aware of what the geophysicists are doing, make the meteorologists aware of what the oceanographers are doing, and so on. And secondly, any system we develop has to consider different conventions and standards for all the different types of data. We've been collecting a very wide range of data. So today I'll talk about the work we've been doing towards one key objective that we've had, and that's to provide an overview of all the data that we collect during a single cruise or for multiple cruises. Any solution that we come up with has to be searchable so that anyone in the project or anyone outside of the project can come along and easily find information about the data that they're interested in. And it also needs to consider the different standards for two reasons. One, it makes our work easier to share and understand. So if anyone wants to adopt the same system as us, they can. But also, it should make it a little bit easier for people to publish their data fairly if they're already considering these conventions when logging their data. So what we've come up with is a single logging system for all metadata data we collect upon a single cruise. What I'm presenting today is not actually what we used during the Nansen Legacy Project, but what we've developed based on our experience of using an earlier version of this logging system in the past 3.5 years. So it works like this. We have a virtual machine on board the ship, on board from Stockholm, and that hosts a PostgreSQL database. The database is a catalog of the metadata, so we don't include any data within this, but we include the information about the data. Now, this database has column headers where possible from the Darwin Core terms and CF standard names, and also a few other terms where suitable terms don't exist. The users interact with this database using a simple user interface that they can access by just plugging their laptop into the network on the ship. And I'll show you how that looks shortly. On Stockholm, they already have a cruise logger where they log sampling activities. So that would tell you, for example, when and where you're having a deployment of a CTD or a trawl or a net or whatever. But what this doesn't tell you is anything about the children of those sampling activities, what fish you're catching in the net, what water samples you're taking. But nevertheless, we can integrate our system with theirs and have automatically all of the activities from the cruise logger, where the instrument crew log them, into the database. I don't particularly like Excel, but a lot of scientists do, particularly amongst the biology community. So people who don't want to use the interface can also firstly take our Excel templates or spreadsheet templates in any other spreadsheet software and log their metadata in there and upload them to the database via the interface. We also recognize that it's important to be able to link together the physical samples that people are taking to the electronic log. University freezers are full of samples that people have no idea what they are and who they belong to. And one of the reasons is that you can only fit so much, well, you can only fit so much information on a little label. So our solution is that every record in the database is logged with a universal identifier. You can represent that as a data matrix or a QR code on a label. And then if you scan that label, you get the UUID, you can go and look within the metadata catalog and find all the metadata related to that sample. So this works two ways. You can scan the system, and if you want to create your labels first and log them later, you can do that. Or you can also log your samples and create labels based on the metadata you've logged. And at the end of the cruise, people want to get their data out, and we use the same templates to also export all of their data that people can export their data into. Okay, so how does that interface look? Because this has been the bulk of what we've been doing over the last year. So this is a homepage for the logging system and what you see first. If you're integrated with the cruise logger, you will see that all of these activities have been harvested automatically. The most recent ones at the top. And if you want to go and log some samples that you have collected from, for example, the CTD, you can go and select the yellow icon that says log samples. Directed to this page. It knows that for a CTD, the most likely children you're wanting to log are some NISC tools bolted around it or some LADCPs attached to it, although you can choose from a long list of sample types if you like. You select the sample type, and the next thing you want to do is tell it how many samples you're logging at the top, and then select what fields you want to log for these samples. For some of them, you're likely to have the same value for every whiskey bottle, for example, maybe your name. And in some cases, you want to provide different metadata for each sample, like the bottle number. Some fields are required, some fields are recommended. So you can go and select whatever you need. There's also an option to add any additional metadata they want to add. And we have the full list of CF standard names that we've harvested from the source XML file and the Darwin Core terms similarly. And some extra fields that we've added where suitable fields don't exist. So once you've selected your setup, you can save it to use later and load it in again, so you don't have to do this every time you're logging the same kind of data. And then you proceed to the phone. Select the information that's the same for all samples. Or at the top right, you have the information about the parent and metadata. You don't need to enter that again. And enter in a table the information that's different for all samples. You see at the bottom, it's possible to generate an Excel file from this. So if the table gets too large and you'd rather use some of the functionality that Excel does have and shortcuts to fill this all in, you can export this and submit it again afterwards. You may then want to, you're then prompted to whether you want to print some labels for these records. I don't know why you'd want to do this for Niskin bottles, but as a proof of concept, let's assume we do. We've already logged our metadata, you can see on the left, and now we can select those fields and include them on the sample. You may notice that you can see the latitude and longitude that have been selected here. We didn't actually log those, but that information has been propagated down from a parent to the child automatically. So you should only need to select the parent activity, and where possible, we try and make it easier for people. They don't have to log anything that's already been logged. And then you can also log any free text as well, whatever that might be. After you've done that, you return to the home page. Now you can see a number 12 here next to the log samples. It tells you that that activity has 12 children. You open that up, you can see all of those. View more metadata if you like. And if you like, then you can log children from those Niskin bottles that might be, for example, the water samples if you're taking multiple samples from the same bottle. And this can go on and on and on with as many levels of a hierarchy as you like. So what you're ending up with is a hierarchical catalog of metadata. And at the end of the cruise, you might want to export that. Perhaps most likely, you're going to want to export all the data with your name on it. So you can find that here. So you hit export, and all the data has been dumped into a template that looks like this. And this is all the Niskin bottles here. Here we can see all the information that's been propagated down from the parents to the children alongside it. So this is all in a standardized, maybe consistent would be a better word, data sheets. And alongside that, in the same XLSX file, we have a metadata sheet. Each row here is mostly from the ACDD conventions, the Attribute Convention for Data Discovery. And the idea here is to provide the users with all the global attributes that they might want to include should they want to publish their data later into a CF-NetCDF file. So firstly, it familiarizes them with them, and also there's requirements and recommendations color-coded so they can see exactly what they need to do. These requirements are what we recommend at the Arctic Data Center, which Lara was presented earlier. Also, they're also the same as the requirements at SIOS. The reason we choose this rather than the recommendations that the ACDD conventions have given themselves is that we think that basically requirements are a better way to encourage consistency than recommendations, which you can somewhat ambiguously interpret. What do I have left?
Minutes. Still have about 5 minutes of talking and
some extra. Brilliant. And the idea, the good thing about having such a everything logged in one place in a somewhat standardized way is that it's then possible to build services upon this. I mentioned at the start is one thing that's important to us is that this should be searchable. So at the end of the cruise, I compiled everything into a single database, and we sent this off to my colleague Magna at the Meteorological Institute. And he provides this interface, which looks very similar to what you saw in Lara's presentation. Actually, it's the same software in Drupal. And you can search for any data from a certain station, any data that you might be associated with, search by date, and even in the full text at the top, you can enter the identifier, the unique identifier you have for each sample. So I've talked about this as though it's one single system, and that's partly true, but also it can be divided into separate sections, which are useful in their own right. So this is all available on GitHub, and in Git terms, we have one repository, And those subtrees, the template generator and a label printing can be used in their own right, and I've been doing so. So the template generator I want to just focus on a little bit. We have that accessible via NoDataNet, and actually it's been promoted quite widely amongst some other data centers who are providing links to that page, and I'll show you how that looks and maybe try and convince you to do the same. So this is the template generator. It has multiple configurations. We have this configuration specific instruction system, but then we have some other configurations that we've added to help people publish Darwin Core archives or CF-NetCDF files. The CF-NetCDF configuration, you can hover over different coordinate variables and get the description of those terms. So again, harvested from the source files on GitHub or wherever they are. The user can select whatever coordinate variables they like. There's a second column here where you can select whether they're cells or discrete points. So if you have data that are if you've got average values for a 10-second time window, for example, you need to include information on the minimum and maximum time within that cell. So you have the option to do this. And then select from a full list of standard names, CF standard names. This is searchable, so you have a text box at the start, you start typing something, and all the relevant CF standard names will be returned. Hover over them and find which one has a description which best suits your data and add that to the template generator. And you hit generate, and you have a template that looks like this. There's a few neat features in this. Firstly, you can see the descriptions have been pulled in as notes. So every time you select a cell, you have the description of that term. This is useful if you're sharing the template around between people. I do a lot of teaching, so this is quite a useful teaching tool as well. And also we have cell restrictions, so it's impossible, well, not impossible, but difficult to enter any text, for example, in a cell where you have to, you're supposed to enter numbers. This is also then particularly useful for Darwin Core archives with the Darwin Core configuration. Just very briefly, a Darwin Core archive is, put very simply, just a collection of CSV files that are zipped together with some XML files on the side. I won't give it a more in-depth description for now, so a bit short on time. But it's very easy to see why an Excel template generator would be useful if the aim is creating CSV files later. And very easy to convert one to the next. So what you have here is in multiple sheets, one for each CSV file or core and extension in Darwin Core terms. You have the option to add further extensions if you like. And we have requirements and recommendations for what should be included for each core extension. It's actually quite difficult to find within the Darwin Core community what is required for each core extension. You have to do quite a lot of digging, so providing the users with this up front really helps. In the process to create a Darwin Core archive, you just export all of these sheets as CSV files and basically just upload them to the machine toolkit, enter some metadata on a form, and it will create the archive for you. It's quite a simple process. And that's it. I managed to get it in within 20 minutes. The QR code at the top will take you to the template generator. If you'd like to share this, if you think it's a useful tool, share it by your websites. Very grateful. And the bottom QR code is a link to my YouTube channel. I give a lot of tutorials on how to create NetCDF files, Darwin Core archives in Python and R, and some talks about the ethics of publishing data. It's my birthday tomorrow, so if you want to do something for me. Thank you very much.
To the night tonight might be a good time to shout him a birthday drink or something. Also,
No, if you want to see me tomorrow.
I'll also say, Luke, you have some very impressive principal investigators between Aragorn, OSR, and Hermione Granger.
Yeah.
So it's a quite distinguished alumni we have. Do we have any questions for Luke? Yes, Taco.
Yeah, thank you. You gave the example of the Niskin models and generated the depths that the Niskins were closed. Can you also add months later, or for instance, the data which were extracted from the samples taken from the Niskin models? So the Niskin models are used to take samples and measure, I don't know, nutrients and other things. And that may be done on board and may also be done a while later on shore.
I think theoretically it's possible, but you would have to be connected to the logging system, which means you need to turn to the ship to do so. And the idea isn't really to publish the data through there, but just to provide an overview of what we've collected on the ship, rather than actually including the data that we're taking from these water samples.
All right, thank you very much, Luke. Much appreciated.